Hey everybody, this is Larry. It's November 15 and this is me trying to do an extra problem. Oops, one button. I'm going to try to do a medium today just because I am trying to do a little bit better about sleeping early. I don't know if that's true. That's why I have these nerdy looking blue glasses. Let me know how you feel about them. I don't know. I don't know what the science is, but hopefully, I mean, these are kind of cheap, so it'll be okay. I had to run it a few times because I don't have premium, but anyway, today's problem is 558, logical OR of two binary grid represented as quad trees. That's kind of funky. Let me get my soda real quick. Quad trees are kind of, not gonna lie, quad tree is a thing that I haven't done in a long time, but you can think about, and this is off my head, so I could be really wrong, because I don't think that I get the concept. I remember the concept a little bit, but I haven't touched them in maybe 10, 15 years, maybe longer. So I don't know. We'll see if that knowledge is necessary. Okay, let's focus. Okay. A binary matrix is a matrix in which all elements are 0 and 1. Given quad trees 1 and 2, you have an n by n binary matrix. Okay, two of these return a quad tree. What's the logical bitwise OR of the binary? What does? What the hey? Yeah, that's what I was gonna say. So, well, I guess it depends on how. I think that maybe I'm also confusing definitions as well, to be honest, because I think the variations of because there's also maybe I'm thinking of well, there's KD trees as well, but I think there's one where it's not a perfect quad. It's you could it's a variable thing, and then you kind of rebalance depending on where things are, instead of like a perfect half and then perfect quarter and so forth. But maybe that's not important. The important part is that it's for me anyway. It's kind of like a tree in that there's a recursive structure, and in each. And it's really just like a four-nary tree, like a quad-nary tree, whatever, right? So it's just a tree with 4 nodes, and that's pretty much it. Okay. I see. What are we supposed to return? Okay, so basically, I see. Are we supposed to return a quad tree or the matrix? Okay, you have to return a quad tree. That's a little bit more annoying. Okay, I guess that doesn't matter. Okay, fine. Okay, so that's kind of... I mean, the way that I would think about this initially is, instead of thinking about a quad tree, think about a binary tree, right? What would I do if it's a binary tree in the same structure? You have a one-dimensional plane. You have, left goes left, or 0 goes left, 1 goes right, and then you have this like intersection of them, right? What would you do? Well, you would just kind of recursively call them. So I think that's basically what we would do. And this is an OR. Okay. So we'll just do it step by step and then try to see how things kind of go. I think the one thing that I have to try to think is whether we have to minimize it. What I mean by that is, if, for example, here, do I have to minimize it? Maybe I do, maybe I don't. I guess it doesn't really matter. It shouldn't be that hard. So, okay. So let's kind of go. Let's have a recurse. We have a node 1, node 2. This is just, the 2 trees. And then now we just have to break it down, right? So, this is just, honestly, not super interesting, but you have to be super careful. I think that's the tricky part about this one. And yeah, okay. So if self dot is, or if node 1 dot is leaf, then do I have to do all the cases? That's what I'm trying to think about, right? So basically, if, and we could write it a little bit, right? So then we return a new node, new node, where the value is node 1 dot value, or node2 dot value. Its leaf is going to be true. It's still a leaf, and then zeros for the rest. I think. I don't know. I don't know how this initialization works. It should be none, but maybe that's fine, right? Okay. So this one should be easy, right? If they're both nodes. Okay. Then if they're both not leaves, then we just have to do a recursion on it, right? So we can do something like, oops. And I know that I'm doing the easy ones first, but that's okay. And the value doesn't matter, so switch 0. They're both not. So technically this would be false, but we have to actually think about this, right? So I'll talk about what I mean in a second. So then now we recurse node1 dot top left, node2 dot top left. Oh, this should be 0 then, right? This is none, because these are nodes, not 1, 0. They should mention these a little bit. The definition is a little awkward here, but okay. So yeah, then oops, node 2 of course, and then top right. Oops, that's wrong. Okay, so you have this node, right? The reason why I, instead of returning it immediately, is because we want to propagate it up, right? So yeah, if we dot top left is leaf, and okay, also if node 1 is none, then we return node 2, right? I think I missed some cases here. Base case. Well, we want to be okay. Well, if node 2 is none, then we return none. Otherwise, we return. Technically, you could return node 2, but maybe that's just not good hygiene. So, dot top left, node dot top right, node 2 dot bottom left, node 2 dot bottom right, right? Something like that, right? That's a little bit awkward. Oh, well, fine. And then if node 2 is none, then we return the same thing but for node 1, right? And this of course assumes that node 1 is not none because we checked for it earlier. Okay. Maybe I shouldn't have done an extra problem, I'm tired. Okay. Wow, a lot of negative downloads or whatever. Anyway, so yeah, so if there all is leaf, and the value is the same, I don't know the order of operation here, so that's why I'm doing this. But when in doubt, okay, then we actually want then we want to set the leaf is equal to true, and then we want to set maybe we could just set v is equal to a new node. Maybe that's easier to type. Then this is, if they're all leaves, and they're all the same, then we can, yeah, that value, it is a leaf, and then just nones, right? because now we get rid of the leaf. Okay. Whew, that's a mouthful. But and then basically now we have to do the other case of, which is very annoying. If no okay, fine. If node is leaf and node 2 is not leaf, then what happens, right? Then what we want to do, I guess, is the way that I'm going to do it is a little bit weird. Maybe we'll see if this works. But basically what I'm going to do is do a recursion and then just split this up into 4 in a way. So we recurse, the value doesn't matter because we need to leave. Oh, but we have to do this thing. Okay, so I should put this into a helper function. Let's do that. Maybe merge. I know, I have to do a lot of fixing. This is not a hard problem, but it is a grinder. And just going through the cases. And I'm a little bit tired. I woke up very early today, actually. I'm very proud of myself, but I think I underestimated, you know, as a result. So yeah, so then now we can just return, maybe merge of this, right? And then now, yeah, now we could do this recursion, but maybe merge. And basically what I'm going to do is, let's see, right? So is this a leaf? I guess not because of the node 1. And if it is, then we can merge anyway. We want to recurse. What do we want to recurse, right? So we can actually recurse node 1 again in a weird way. I don't know if this is true, to be honest, but the reason is because if you think about, or the way that I think about it, and maybe I should just use a sentinel instead, but the way that I think about it, if node 1 is a leaf, whatever value it has, you can almost think about it as recursively going down to all the other values. And this is just me being lazy, because I think that is maybe a kind of a dubious code and logic, but I'm sticking to it. So yeah. Top right, bottom left, bottom right. And then lastly, the other one is just node 1 is not a leaf and node 2 is a leaf, right? So yeah, so we can do the same idea. I think the order doesn't actually matter, so it is easier to keep track. And that's pretty much it. So now we want to recurse, what is it? What do they call it? Tree 1 or something? Quad tree 1? I don't know if this works, because I don't know that this is good, but let's give it a spin. It may tell you, because I don't know that I missed a case or not. Okay. Oh. What am I doing? Oh, so the left node, it's going to, what am I doing here? Huh, that is weird. I used a weird syntax. But basically I want something like this. Okay, I messed up. So we want to say the left node is going to be, oh no, this is right. I just kind of did, I don't know why I have a recursion here actually. That's the, I meant to have a node. I think this is right, because now you're creating a new node. Okay, fine. That was just me. Maybe I just got confused because there's a lot of stuff to type and I'm old and tired and need my beauty sleep. Okay, that looks okay for these two cases. That doesn't mean anything, but I am lazy, so it's good enough for me to submit, and let's see what wrong answers are. Oh, there you go. Good try on the first try. I kind of did a lot of hacks on this one, to be honest, so I don't know that I recommend it, but this is linear in the size of the input in that, we only look at every node once, so this should be good. There are a lot of edge cases, so I think, like I said from the beginning, the tricky part is being clean and making sure that you go for the cases. Like I knew there are 4 cases here, and then I also knew that there are 4 cases here, just because that's how 2 to the 2 works. And luckily, I did a maybe merge thing, so I don't know if this is necessary per se, but it definitely helps, I guess. They didn't. Did they have an example? I don't know that they have an example with this. Or at least I didn't know if you have to minimize it. But yeah, this is going to be linear time, linear space. And that's all I have for this one. So let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.